Its title is Identification of Landslides and Vegetation Recovery Assessment after Hurricane Mitch in LAC and El Altobar, Honduras. Okay, please.
Okay. Hello everyone. My name is M C Valdez. I'm from National Central University. My topic is identification of landslides and vegetation recovery assessment after Hurricane Mitch, which occurred in Honduras. The study area is La Ceiba and El Porvenir. The contents of the presentation will give a brief introduction, background, objectives, show the study area, methodology, results, and the conclusions of this topic. The study area is located in Honduras, Central America, which is a country with a good location in the center of the continent, but has negative consequences since it's constantly affected by hurricanes, tropical storms, which cause floods and massive landslides. As I mentioned, it's exposed constantly to natural disasters, which the causes of this is the local vulnerability, location, also the strong degradation of natural resources, and hurricanes, which are the climate extreme phenomena, cause floods and massive landslides. In 1998, October 1998, the Hurricane Mitch occurred. It's considered to be the most deadly hurricane in the Western Hemisphere in the last 2 centuries. It has a category of 5, and total rainfall is 1,900 millimeters, and caused floods and mudslides, which destroyed almost the whole country's infrastructure and its production. Only the landslides damaged 70% of the road network and caused 1,000 fatalities, only from landslides, although the total disaster caused 12,000 fatalities. And at that time, there is no estimation of occurrence of landslides in the whole country, only in selected areas. The objectives is identify the landslides triggered by Hurricane Mitch in La Ceiba and El Porvenir counties in Honduras, and also vegetation recovery assessment for these landslides for 2 periods: 1999-2005 and 1999-2011. The study area is Honduras is located in Central America, and the study area is located in the Atlantic coast of the country, and it has a total area of 92,435 hectares. The importance why we selected these 2 study areas. One is because they both conform the National Reserve called Bonito, and are part of the Cangrejal River watershed, which provides water to the 3rd largest city in the country. During Hurricane Mitch, also these 2 counties were practically uncommunicated for 1 week due to the landslide occurrence. And also because of the National Reserve has a mountainous relief with strong slopes, so this area has a high probability of landslide occurrence, which became evident after the Hurricane Mitch in 1998. Our methodology, the methodology that we developed is divided into 4 steps. First, the acquisition of data, data pre-processing, which we did some atmospheric and terrain correction, gap filling of the landslide scenes, some landslide identification using the widely known CVA, noise elimination using different filters, and we use for the vegetation recovery assessment, we use an index called BRR. For the ground truth, firstly, we selected a landslide. We used a landslide inventory, which was developed by USGS in the months after the Hurricane Mitch, although this was developed only in some specific areas. The inventory was developed using aerial photographs, and their outlines were sketched by hand onto topographic maps. And the Landsat scenes that we acquired as images pre and post hurricane, and the images for the vegetation recovery rate estimation. For the data pre-processing, we did an atmospheric and terrain correction. We use the AdCore module, AdCore 3, using Erdas Imagine. And the process is we have the input of an image, haze removal, including a DEM, and the derived slope, aspect, sky view, and shadow. We develop the atmospheric and terrain corrections, and we have the result of this corrected image. Also, we do some gap filling of the images, which was developed in 2 stages, replacing the bad pixels by mapping image of the recent date, and also replace the bad pixels with interpolation within an homogeneous area. We use 2 Landsat scenes as reference, one of similar date or close to the date of the processing, and one SLC on images, which is before the 2003. For identification of landslides, we use the widely used for change detection, change vector analysis, using spectral differences to detect the change, and using the 2 dates, image pre and post hurricane image, using 2 bands. As I mentioned, we use the pre and post hurricane image scenes. Firstly, we measure the magnitude of the change, and secondly, the direction of the change. For the landslide identification, we use the red and the infrared bands for each date. Hence, the difference of between the pixels can be expressed as the Euclidean distance between them in space, using the equation as follows, in which the S is the magnitude of the change of the vector, red B and red A is the red bands of the image before and after, and the near infrared band of before and after are also used. The direction is also estimated to assign the type of change, in which the second quadrant is where the pixels that fall in the second quadrant are of our interest, in which there is a bare soil increase, which the near infrared decreases and the red increases. We also, after we do the CVA process, we do some landslide filtering to eliminate undesirable change pixels, because change can be a road, change can be any other type of change from vegetation to bare soil. So first we divide the area, steep land and flat land. We use 10 degrees as a threshold, as the ground truth is all of the minimum value of the slope of the ground truth is 10 degrees. So we use that as a threshold to eliminate or to divide the flatland into flatland and steep land. We also use a shape filter, as according to the ground truth, 98% of it is debris flow. So most landslides have occurred after the hurricane Mitch are debris flows. So we use this ratio of dividing the perimeter of the landslide and the area of the landslide, and also the minimum R for the ground truth is used as a threshold. So if the ratio is higher than the threshold, is landslide. If not, it's not landslide. And the majority filter to eliminate noise present in the image. For the vegetation recovery, the 2 periods selected, 2005 and 2011. To develop this, we use a vegetation recovery rate, VRR. And to estimate the VRR, we use NDVI. Firstly, we estimate the NDVI of the 4 images that we is we have the NDVI-2, which is for the period of evaluation for vegetation recovery. NDVI-1, which is estimated soon after the hurricane, the post-Mitch scene, and NDVI-0 is the pre-Mitch or the pre-hurricane scene. And if the values range from 0 to 100, there is some vegetation recovery. If the value is greater than 100, the recovery is better than before the hurricane, and less than 0 is worse than after the hurricane. For the landslide results, we could identify using the Landsat image 742 landslides with a total area of 1,563 hectares. These are some of the samples of the landslides we could identify with the Landsat scenes. The accuracy assessment, we have an overall accuracy of 84, user accuracy of 65%, producer accuracy of 77, and the kappa coefficient of 61%. And regarding the vegetation recovery rate, we plotted this graph of the results. We divided firstly into 6 categories, which is no recovery, the low recovery from 0 to 25, average from 25 to 50, high from 50 to 75, very high 75 to 100, and excellent, which is higher than the better than before the hurricane. And we see that in the 2 years, in the first period, mostly the recovery is mostly located in the average in the average category. And in 2011, it increases to the very high, although the excellent category is still keeps low. And these are some of the samples of the vegetation recovery rate for the two years. And as a conclusion, we can say that this kind of change detection methods can be used for large areas, for fast assessment and identification of landslides, using satellite images that are freely available. Also, the vegetation cessation cannot be accomplished in a short time, although the results reveal stable plant growth and vegetation recovery tendency for the deletion sites. Especially in the National Reserve area, artificial vegetation recovery is required to some extent to accelerate the recovery. Also, the VRR in the category of excellent is still low. This is probably because in La Ceiba and El Porvenir, most of the forest present is tropical rainforest. So also they have a national reserve, which is before the hurricane, before the massive landslide events. There was the density was very high. It was difficult for it to become better in such a short time, to have a better condition in such a short time. Thank you for the attention.
Thank you for nice presentation. So, is there any comment? Yes, please.
Thank you for presentation. Could you show me again slide number 17?
17.
Yeah. Yeah. This written, you think is right or wrong? This formula, this formula.
It's wrong. I typed wrong.
Yeah. to be minus, not plus.
Yes.
And in CBA methods, we are using two values. The first is magnitude, yeah, and the second is angular. That
Yeah.
means the direction of chain reaction. Yeah? I'm not sure you're not using the angular.
Yes.
Is it?
Yeah. Yeah. I didn't put the equation, but yes, we use the angle too.
Yeah. So is it using the magnitude, not using the angular?
We use magnitude and angle.
Thank you.
Yes, please.
Thank you for nice presentation. Can you show me slide number 15? 15.
15.
Yeah. No, gap filling slide which is showing gap filling. Sorry.
I don't understand. Which one?
Gap filling of images.
Yeah. Oh, okay, fitting.
The first image of 2009, image A. Which year's image? Image 1.
We fill the images of 2005 and 2011.
So some gaps are there in 2005 images.
2005 and 2011 has gaps because of the SLC of.
So you have used these gaps using the same year's image or current year image?
We use, to fill the gaps, you mean? We use one with similar date with gaps because the gaps are not in the same position. And
Okay.
also SLC on previous for the filling that cannot be done.
Okay, thank you.
Okay, yes, please. I would like to know, what was the average recovery rate in your study area? Lungs recovered within 2 years or 4 years or 5 years? You studied from 2005 to 2010.
Okay, so the period is 98 to 2000. 98 to 2000.
I would like to know, what was the average rate of recovery of the vegetation in your study area?
We divide the average or the percentage only. We didn't put the average.
I mean, how many years it will take to recover the vegetation after the landslide of hurricane?
The thing is that we put percentage and we didn't estimate the average.
Because you studied
years.
temporal data, you studied
Yeah,
temporal
and-
data, so
and-
you could find.
And as the 2011 is still not recovered, but the thing is that we didn't evaluate other events that happened because in the middle maybe other events happened or more landslides occurred. So we cannot estimate how much time we will recover.
Okay, because that's interesting, some study is interesting, so please try that. Thank you.
Okay, can you show your conclusion? I would like to make a comment on your conclusion.
First or second?
Next. Okay. According to the past experience in Taiwan, artificial vegetation recovery were not very useful. I would like to tell you the truth. I come from the Department of Forestry, National Chongqing University in Taichung, and you are studying in the Central University. Okay, actually, not very useful. Just waste money. Thank you.
Is there any question or comment? It's okay? It's time. Thank you again, Mr. Valdez. Okay, this session, 5 presentations for this session is finished. This session is over. I
Christian